Hey guys, I'm Miss Hayes and I'm going to be doing some videos for you to help you better understand some of the material in your geometry class. Please make sure that as you're watching the video, if you need to pause it or go back in the video, you can work at your own pace. That's the advantage of these videos, and how I think that they're going to help you in the classroom is it allows you to work at your individual pace so that you can better understand what it is that you're learning. Now, as you're working through these, please remember that you can ask questions. You still have a teacher in the classroom that is able to answer questions, but this will free her up to actually move around and work more one-on-one with you. So let's go ahead and get started. We're going to be working today with what is called segment and angle addition. First thing we're going to start with is our consider this question that we have up at the top here. It says you have two hardwood floorboards that are going to be placed end to end. One of the boards is 6 feet long. The other board is 4 feet long. So let's go ahead and label what we know on the picture to see if we can figure out the answer to our question here. So our first floorboard here is 6 feet from here to here, and our second floorboard is 4 feet from here to here. Now, the question that we're asked to answer is what is the length of the floor that is going to be covered by the two boards? So essentially what we're trying to figure out is what is this total length from the left end of the boards to the right end of the boards. Now, of course, if we put those two boards together, that is addition in math. So what we're going to do is we're going to add those two boards together, and our total is going to be 10 feet. Now, that probably seems pretty much like common sense, and it is. And that's what's nice about the segment and angle addition postulate, is that it follows along with that basic idea that when you put two things together, you add them in order to figure out the total. So what we say in more user-friendly terms is that the sum of the parts is going to equal the whole. Now, you use that concept every single day. Let's say you're trying to pull your money to buy something. You know that each person's money is added together to figure out the total amount of money you have to purchase what you need to purchase. So the sum of the parts equals the whole can be applied to just about anything. Today, we're going to be focusing on using that to solve for some missing pieces in a segment. So let's take that information and let's look at the segment addition postulate, which is down here at the bottom. And what the segment addition postulate basically says is that same thing, the sum of the parts equals the whole. So if you have a segment that is broken into two pieces, if you add those two pieces together, it's going to equal the total length of the segment. So what we're going to do is we're going to use that today to actually solve for some missing pieces. So let's go ahead and take a look at some examples. So looking at example number 1, I noticed that I do have a segment broken into two pieces here. So this is going to use the segment addition postulate to solve for some missing pieces here. Now, first thing that I want to do, and one of the biggest things that you want to get used to in geometry, is making sure that you're reading the question and identifying any key information that may need to be added to your diagram. I noticed that I have the length of EF here, and I have the length of FG here, but I also have a piece of information that's given to me up in the problem here, which is that the length of EG is equal to 59. So let's take that piece of information and let's add it to the diagram. Now, EG represents the length of the entire segment. So I'm going to go ahead and label that entire segment 59 units. So here we have 59 from our left end to our right end from point E to point G. Now, I also notice in the problem that I am trying to find the length of EF and FG. Now, looking at where EF and FG are, in order to find the lengths of those two segments, I notice that there's a variable included in here. You learned back in algebra that in order to work with a variable, you are going to need to set up an equation to solve for that x. So I know that in order to find the length of EF and FG, I'm going to have to first figure out what the value of x is. So let's go ahead and let's use our segment addition postulate to actually write and solve an equation. Now, what that segment addition postulate says is that if you take the sum of the two parts, so what I want to do is add these two pieces together, it's going to equal that total that we have down here at the bottom. So if I were to turn that into an algebraic equation, I'm going to add the 8x minus 14 plus 4x plus 1, and that's going to equal 59 units. Now, from here, your algebra skills should be taking over at this point. We're going to solve this like a regular algebraic equation. You learned back in Algebra 1 that there are two sides to an equation, and you want to work on each side individually before you start moving terms. Now, what I notice on the left side of my equation is that I have x terms that can be combined, and I also have number terms that can be combined. So I'm going to go ahead and combine those like terms. 8x and 4x is 12x, and then negative 14 plus 1 is negative 13. Now from here, I'm sure that most of you are pretty comfortable solving. This is a basic two-step equation from here. So now that we have everything cleaned up on this left-hand side, we need to start moving terms over to the right in order to get this x by itself. Now I do have to move the 13 first because I cannot touch the 12x until that term is isolated or by itself. So I'm going to add that 13 to the other side, so that leaves me with 12x is equal to 72. I'm going to divide both sides by 12. So I end up with x equaling 6. Now, one of the things that you have to be super careful with in geometry is making sure that you're actually reading the question and you're answering it appropriately. So if we look back at the question that was asked, we had to solve for x, but the two final pieces that we were asked to find were the lengths of EF and FG. So in order to find the lengths of each one of these segments, we're going to have to take our value of x and we're going to have to plug it back into the expression here. So let's start with EF. In order to find the length of EF, I'm taking that 6 and I'm plugging it in for x right here. So that's going to become 8 times 6 minus 14. And when I calculate that, I end up with EF equaling 34 units. Now, I want to do the same thing with the other piece. I'm also asked to find FG, so I'm going to take my 6 here and I'm going to go ahead and I'm going to plug it into FG as well. So for FG, I'm going to end up with 4 times 6 plus 1, and FG will equal 25. Now, there's a really easy way to check your answer, which takes about 2 seconds to check your answer. If your x was wrong, when you add these final two pieces together, the 34 and the 25, if you add those two pieces together and it doesn't equal 59, you know that your value of x was incorrect, or you may have plugged into the segments incorrectly. So make sure that you take that 2 seconds to actually check your answer. 34 plus 25 does actually equal 59, so I know that I have answered my problem correctly. All right, moving on to example number 2, I'm going to start moving through the solving process a little bit quicker now, since that's an algebra skill. So if you do need to pause the video or go back in the video, please do so, but you're going to see me start to move a little bit quicker because y'all are going to start catching on at this point. So in the second example here, we have segment JL, and we know that JK is equal to 4x plus 6. We know that KL is equal to 7x plus 15. And we also have this piece of information given to us in the problem that JL, which is the entire segment, is 120 units. So I'm going to go ahead and label that on my figure. Now, the next thing I'm going to do is make sure I read my question and I figure out what it is that I'm trying to find. I notice that there's an x, so I'm probably trying to find x, but I also know that I am going to need to plug back in at the very end of this process to figure out what the length of JK and KL are. So using our segment addition postulate once again, our postulate says that the sum of the parts is going to equal the whole. So if I put these two pieces together, it is going to equal that 120 again. So let's write our equation just like we did in example number 1. So 4x plus 6 plus 7x plus 15 is equal to 120. Now, once I have my equation set up, I want to go ahead and combine my like terms on the left-hand side. So 7x plus 4x is 11x. Positive 6 and positive 15 is positive 21. We want to subtract that 21 to the other side of the equation. We get 11x is equal to 99. Divide both sides by that 11. So x ends up equaling 9. Now, I know that that's not my final answer because I was asked to find JK and KL, so I know I am going to need to take that number and plug it back in. So, using the expressions that I have above, let's start with JK. I notice that JK is 4x plus 6. So if I put my 9 in for x, or if I plug my 9 in for x, I have 4 times 9 plus 6. So that will give me JK is equal to 42. Now, I want to do the same thing with KL because I'm also asked to find KL. So I want to take my value of 9 and plug it in up here. So that's going to end up becoming, for KL, 7 times 9 plus 15. So KL is going to equal 78 units. Now, remember I told you in the last problem that there's a real quick way to check to make sure that your answers are correct. You want to take your 42 and you want to add the 78 to it and make sure that it actually equals that total of 120. When I added 42 and 78, I did get 120, so I know that my value of x must have been correct. Moving down to the bottom example that we have here, which is example number 3, I notice that I don't have a diagram given here, and in geometry, one of the most important things is to be able to visualize and understand where the pieces lie on your segment. So the first thing that I'm going to do here is I'm actually going to create a diagram of the situation here. So what I'm told in the problem is that point B is on segment AC. So I know that the first thing I have to do is have segment AC. So let's go ahead and draw segment AC here. We'll start with point A and end with point C. And I'm told that B is somewhere on that segment. It does not matter where you put B. You can put it right in the middle. You can put it towards the left, towards the right. It really doesn't matter. This is just a sketch of where everything is located. It's not drawn to scale at all. So I'm just going to go ahead and put B anywhere on that segment so that I know where the points are located with respect to each other. Now, I am told that AB is equal to 2x plus 7. That's this piece right here, so let's go ahead and label that. I am told that BC is equal to 4x minus 3. That's this piece right here. And I'm also told that AC is equal to 46. And AC is the entire segment here. So using what we've learned in the previous examples, we can go ahead and set up an equation using that segment addition postulate. So the sum of our parts is going to equal our whole. So I'm going to add these two pieces together and set it equal to that 46 that's there. So 2x minus 7, or 2x plus 7, excuse me, plus 4x minus 3 is equal to 46. I'm going to solve that equation by combining my like terms first. 2x and 4x is 6x. 7 minus 3 is positive 4. Subtract that 4 to the other side of the equation. So 6x is equal to 42. And I'm going to divide that 6 out on both sides. I'm running out of room down here at the bottom. And 42 divided by 6 is 7. Now, what I noticed when I go back and read my question, I was asked to find two things. The first thing I was asked is to find the value of x. So this is my first answer. And the second thing that I was asked to find is the length of AB. And AB is this piece right here. So I do not need to plug into this expression because I was not asked to find the length of BC, only AB. So I'm going to take my value of x and I'm going to plug it into this expression only. So for AB, I have 2 times 7 plus 7. So AB is going to equal 21. So on our last example on the front side here, you're going to notice that there's something just a little bit different about this problem. What you've probably noticed if you've read the problem so far is that there's not a total value given to us in the problem. So we don't have anything to set the equation equal to. So there's got to be something a little bit different happening in this problem. So we've got to make sure that we read the question at the top and identify any key terms that might help us. So what I'm told at the top is that U is the midpoint of TV. Now, I know that we've seen midpoint before in this class, so that's probably a pretty important term, and it turns out that it is. What you learned earlier in this module is that a midpoint is directly in the middle of a segment. So a midpoint is going to divide the segment into two congruent pieces. So if this is right in the middle, then TU has to be the same length as UV. So I can mark these two pieces as being congruent to each other. Now, because those two pieces are congruent to each other, I actually don't have to have a total because what I know is that these two expressions are going to be equal to each other. So that's exactly what I'm going to do for my equation is I'm going to set those two pieces equal to each other. So I'm going to take 8x minus 11 or 8x plus 11 and set it equal to 12x minus 1. Now, this equation sets up a little bit differently than the ones that we've seen before in that you have variables on both sides. Remember from Algebra 1, you were told that if you have variables on both sides, your goal is to get all of the variables over on one side to start with. Now, you can move your variables either to the left or to the right. It doesn't make a difference. I always move my variables to the left just for consistency. So I'm going to go ahead and subtract 12x. Because that was a positive 12, and the opposite of positive 12 is negative 12. 8 minus 12 is negative 4x, plus 11 is equal to negative 1. Now, once I have all those variables over to the left-hand side, I'm left with just a basic two-step equation. So once I have the variables to the left, I want to get all those numbers over to the right. So I'm going to go ahead and subtract that 11. So negative 4x is equal to negative 12. Divide both sides by negative 4. And I end up with x equaling 3. Now, looking back at my problem, I noticed that I'm not just asked to find x, I'm asked to find the length of TU, UV, and TV. So that's kind of a lot of information to process at one time, so let's take one step at a time. Let's start with TU. TU is this piece right here. So just like we've done in the previous examples, we're going to take that 3 and we're going to go ahead and plug that in for x. So for TU, it's going to end up being 8 times 3 plus 11. So TU is going to equal 35. Now, looking at the second piece, and I can kind of check this off, I've done TU. Next up is UV. UV is this part of the segment right here, so I want to take my 3 and plug it in. So UV is 12 times 3 minus 1, so UV is also equal to 35. Now, that's not a coincidence, and some of you may be asking yourself, well, why couldn't I just automatically say that UV is equal to 35 because I knew that these two pieces were equal to each other? You always want to plug back into everything that you have because it checks your answer in the process. So if you had plugged X in here and X in here and gotten two different answers, then you would have proven that your X cannot be correct. So I always plug into everything I have so I can check my answer in the meantime. Now, I'm going to go ahead and check UV off because I found UV. Now, the last thing that we're asked to find is the length of TV, which is the entire segment here. Now, that piece is the total of these two values right here. So in order to find TV, I want to add the 35 plus 35. So I know that TV is equal to 70 units. And I ran out of room there at the bottom. Sorry about that. Now, we have completely answered the question because we have found all three values, and we are done with our final example on the front page. Now, moving on to the back side of your notes, we are working through the angle addition postulate today also because the postulate basically says the exact same thing the segment addition postulate says. It just works for angles instead of segments. So what the angle addition postulate is going to tell us is that if you have an angle that is broken into two pieces, if you add those two pieces together, it is going to equal the entire angle. So when we are looking at what that means as far as real world style, again, we're going to have the same basic definition for this in that the sum of the parts is going to equal the whole. So we're going to add that to this little box over here. And again, what we said before was that that basically means if you add the parts of whatever it is that you have, it could be segment pieces, it could be angle pieces, it could be money, it really could be anything. We started with floorboards at the beginning of this lesson, that if you add all those pieces together, it's going to equal the total. Now, that's pretty much the definition of a sum or of a total in mathematics. So again, pretty straightforward here. So this second part of the lesson is going to go pretty quickly because it's going to set up and solve the exact same way as the first part. So let's take a look at our first example. Again, we want to make sure that we're paying attention to what is given to us in the problem and what we're asked to find. Now, I noticed that this angle ABC here is labeled with a 4x plus 2. I noticed that this angle CBD is labeled with a 3x minus 7. And I also noticed that there's a piece of information given to me in the problem that ABD is equal to 100 degrees. Now, looking at the angle, ABD is the entire angle. So what I'm going to do is go ahead and label that entire angle 100 degrees. Now, what our angle addition postulate tells us is that if we add our two pieces, just like with our segment, it's going to equal the entire piece, whether it's a segment, an angle, whatever it is. So I'm going to write my equation exactly the same as I did on the previous section, and I'm going to do 4x plus 2 plus 3x minus 7 is equal to 100. Now, going through and solving this, I'm going to solve it pretty quickly because we've already reviewed how to solve algebraic equations in this section. So, combining my like terms on the left-hand side, 4 plus 3 is 7x, positive 2 minus 7 is negative 5, is equal to 100. I'm going to add 5. So I have 7x is equal to 105. Divide both sides by 7. So x ends up equaling 15. Now, going back and looking at my problem, I was asked to find 3 things, so I want to make sure I completely answer the question. The first was to find the value of x, which I have already done right here. The second was to find the value of angle ABC. Angle ABC is this left-hand piece right here. So it's the 4x plus 2 portion. So I want to take my 15 and I want to plug it into my expression here. So for angle ABC, it's going to be 4 times 15 plus 2. So angle ABC is going to equal 62 degrees. Now, I'm also asked to find the measure of angle. I'm just changing the color real quick, which is why it's taking me a second here. I am also asked to find the measure of angle CBD, which is this piece over here. So angle C to B to D is the 3x minus 7. So I have angle CBD is equal to 3 times 15 minus 7. And 3 times 15 is 45. 45 minus 7 is 38. So angle CBD is going to equal 38 degrees. Now, I have answered all 3 parts of the question, so that tells me I'm done with this example. Now, our last example here is just like the previous one. So I'm actually going to get you started on this one, and I'm going to let you actually practice and work through this one on your own. But just to give you an idea with starting this problem here, again, it works out the same way our previous example does. We have our 2 pieces identified and labeled here, and we also have a piece of information given to us in the problem. So we want to figure out the value of x. We want to find the measure of angle ADB and the measure of angle BDC. So first thing I'm going to do is I'm going to label this angle because I notice this says ADC from A to D to C is the whole angle. That is my 56 degrees, which tells me that if I add these 2 pieces here together, it is going to equal the total of 56 degrees. So I have x plus 7 plus 2x plus 19 is equal to 56. Now, from here, I'm going to give you a chance to actually try to solve this one on your own. Please remember to answer all parts of the question. So you've got to complete this equation solving here, and then you do need to plug in to find each one of the angles. Remember, you can always check your answer by adding your 2 angles together and make sure that they actually equal that total of 56 degrees. So if you want to check your answer, it only takes about 2 seconds once you figure out these 2 pieces.